All right, so we just want to take a few minutes and just kind of go over the test corrections. Okay, so again, on multiple choice, you want to put the right answer and a reason why it's the right answer, not why you missed it, but the reason why it's the right answer. Now, I want to go over a couple of these that were kind of highly missed. First off, let's look at number 8. The weakest intermolecular forces exist between molecules of. When you look at all 4 of those A, B, C, D choices, what type of substances are all 4 of those?
Hydrocarbons.
Hydrocarbons, okay? So the ionic, metallic, covalent network, covalent molecular. Well, what type of elements are making them up?
Covalent.
2 nonmetals, right? Carbon, hydrogen always acts like a nonmetal. I mean, it's a gas. Okay, so that means it's what type of substance?
Covalent.
Covalent. Is it one of our 5 covalent networks? What does that mean it is?
Covalent molecular.
Covalent molecular, right? Now, in covalent molecular, then we have the IMS, and so this is kind of even the fact that it says intermolecular forces, only covalent molecular form molecules. Okay? That's why they call it covalent molecular, because they form molecules. So, what type of molecules are those, polar or nonpolar? Is there a phone call in there? Do any of these have fluorine, oxygen, nitrogen, or chlorine? No. Remember, hydrocarbons are always nonpolar. Hydrocarbons are nonpolar. So what's the only type of IMF?
LDF.
LDFs. And what do LDFs strength vary with?
Size.
Size, and specifically the size of the electron cloud. Now we can look at molar mass, because electron cloud and molar mass go hand in hand. Bigger molar mass, more electrons. But it's really technically the size of the electron cloud. So which one of these is going to be the weakest? The one with the least amount, which is?
C.
C.
I did that one almost without the scientific stuff.
You just knew it was the biggest or the smallest one? The weakest has got to be the smallest one. But it's because they're non-polar, therefore they have the weakest LDFs. Okay? And number 9. Which one doesn't conform to the octet rule?
I didn't have enough time to draw these out.
Boron.
A. How do I know that without having to draw them out?
Because boron only needs 6.
Boron and aluminum, really group 13, only needs 6 electrons. That's the exception to the octet rule. So whenever it's the central atom, you know it has only 6, not 8. Okay? So that's the key right here, is the boron. Were there any others 1 through 10 that you guys have questions on? Anybody have a question 1 through 10? All right. 11. Okay, so how do I know number 13? What's the only substance that conducts electricity as a solid? Metals. So you find the metal, the only metal is silver. Okay? And I hate it when that happens, and I normally catch it and I missed it on that one. Because then you tend to lose the AGCL down there. But okay. Any questions on 11 through 15? We're good? What does amorphous mean on A? They form amorphous structures.
Random.
Random, no ordering, okay? But we know that ionic compounds form what we refer to as crystal lattice structures, okay? They're very orderly. The ions are positive surrounded by negative, negative surrounded by positive. So amorphous is the opposite of crystalline. Amorphous means random, crystalline means ordered. All right, so are ionic solids amorphous? Do they conduct electricity? Are they malleable? Do they have high melting points?
Yes.
Okay. Okay, look at number 19. Which molecule contains polar covalent bonds, but the molecule is nonpolar? What are the 2 criteria for a polar molecule? gotta have what?
Polar bonds.
Polar bonds,
And has to be
and
asymmetrical.
has to be asymmetrical. Okay? So we're looking for which one has polar bonds. Does this one have polar bonds in it? So we can eliminate that one. Okay? Polar bonds. What type of bonding is present here? Where's barium located on the periodic table? Number 56. So it's a metal or non-metal?
No.
So what type of compound is this?
Ionic.
Ionic. Polar doesn't apply to ionic. It only applies to covalent, so we can eliminate that one. So now it's between these two. What do we know about water automatically?
It's polar.
It's very polar. We've used it as the example for polar the whole time. Now, so why is this one? Now, first off, how do I know it's got polar bonds?
It has CO.
Chlorine, fluorine, oxygen, nitrogen, chlorine. If one of those four, it's probably going to be polar. But why is the molecule nonpolar?
Because it's
Symmetrical.
unsymmetrical.
Because it's symmetrical. Okay? The shape of it is tetrahedron. All right? 21. Which of the following does not form molecules but instead forms large crystalline structures? What type of compounds form large crystalline structures?
Ionic.
Ionic. So you go and you find the ionic one. Okay? Is 15 degrees a high or low melting point? Low. Okay? What's the only type of substance that has low melting points? Covalent molecular. All the others are all solids at room temperature. These are the ones that are liquids or gases at room temperature. That's just knowing the properties. Then, just an FYI, this question right here came off of, I stole it from an old chemistry 1 freshman chemistry test at LSU. So this is a college level test question. Right here. It's off of old, now it's LSU, so, but, but anyway. So what does this mean? Now this is important. When bromine and ICL have nearly the same molecular weight. If they have nearly the same molecular weight, what is that? What IMF does that tell us something about?
LDL.
LDS. If it's nearly the same molecular weight, they have nearly
The same LDL.
same LDF. Okay? So that's an important thing right there. So you need to know that whenever it says that means the same, but yet they have different boiling points, which means one must have some other type of attractive force as well. Well, Br2, is that going to be polar or nonpolar? Nonpolar, because the difference in electronegativity is 0 when you subtract them. But ICL, it's got chlorine in it, that makes it polar, so what other IMF does it have?
Dipole.
Dipole. So it's got nearly the same London forces, but this one has additional dipole, so ICL is polar, which gives it the extra attractive force. Okay? Any questions at all about any of the multiple choice now? You mad at yourself for missing any of them? No? You didn't miss any of them. All right. Why are ionic solids brittle? Now we need to answer this. A lot of y'all were very skimpy on your answers on this. Okay? Ionic solids are brittle because when you hit them, what happens?
Shatter.
Why do they shatter?
Because the,
Okay, what did he say?
the positive meets positive and
Positive meets positive and negative meets negative, so they repel and shatter. But why are metals malleable?
because they have room to move around. Or,
What moves
Oh.
around?
The
Okay.
sea of free floating electrons.
Can move, keeping what from happening?
A positive.
From positive get next to positive or negative get next to negative. Okay, so that's what you need to say. You need to write about both of them. Ionic solids are brittle because when hit, it forces positive next to positive and negative next to negative, or like charges together, which cause them to repel and break into small pieces. Metals have a sea of free-floating valence electrons that can move, which keeps positive from getting next to positive. So go ahead and take a second and answer that one. Who is missing today? Is there anybody out here? Oh, yeah, he's in Clay's situation.
I still can't taste nothing. You know how terrible that is?
Oh, really? Oh, you actually
Can't
have?
taste it.
Yeah.
Oh, I thought you were just quarantined.
This is miserable. You can't taste food.
I need that. I need to lose some weight.
I
You
like
need
it.
some food this
New Year's resolution?
It wasn't a New Year's resolution, it was for a 3-week time period. And so, I made it through the 3 weeks. All right, now, a lot of y'all on here, solid K conducts an electric current, whereas KNO3. So solid K is what type of substance? Metal, whereas KNO3 is ionic. Okay? Now, a lot of y'all said that. Potassium conducts electricity because it's a metal. Well, why? What about being a metal allows it? What's the key phrase?
Free floating.
Which allow, now listen. Number one, in metals, C of free floating valence electrons. So it's electrons flow through the metal. Okay? Metals don't produce electricity, they just allow electricity to flow through it. Okay? So potassium is a metal which has a C of free floating valence electrons, which allow it to conduct electricity because it has charged particles that can flow. By the way, it's 4 points for number one, 2 points for why ionic solids are brittle, 2 points for why metallic solids are malleable. And it's going to be the same thing here, 2 points for why potassium conducts electricity and 2 points why KNO3 does not. So what is KNO3 composed of? It is a crystal, that's the order, but if it's an ionic compound, what's the smallest particles making it up? Ions. So it's not electrons flowing through a salt, it's the ions that's the charged particle. But why can't the solid conduct? Not the electrons, the ions are held rigidly in place and can't move. Okay, so KNO3 does not conduct electricity because it is ionic and the ions are held rigidly in place and cannot move. Okay, so in metals, it's electrons that's the charged particles, and in an ionic compound, it's ions. So if I put salt into water, salt dissociates, breaks apart into Na plus and Cl minus. Now the ions have mobility, so the solution will conduct electricity. But it's ions allowing the charge to flow through. So I kind of corrected that on some of y'all's as you're writing. I changed the words from electrons to ions and the such. All right, the last one I'm going to go over.
Wasn't there a B in there?
Yes, last one I'm going to go over is B. Okay, you got CCl4 and CBr4. What type of substances are both of those? Whenever you're dealing with boiling point, you have to know what you're dealing with. What type of attractive forces? You were right the first time. They're both, what type of compound though? Covalent, polar or nonpolar? How would we know? It's going to be a symmetrical molecule, right? It's all the same thing around it, CCl4. It's going to have the 4 chlorines around the carbon. This is going to have the 4 bromines around the carbon. So they're both nonpolar. So what's the only type of LDF? What's the only type of IMF? LDFs. Okay? And with what do LDFs vary?
Electron cloud.
The size of electron cloud. So both CCl4 and CBr4 are nonpolar covalent molecules whose only IMF are LDFs. Because CBr4 is larger than CCl4, its LDFs are stronger, thus it has a higher boiling point.
Okay, can you slow down and go back about 3 sentences?
Well, again, you can put it in your own words.
I am, I just have to like
Okay.
hear it.
What type of substances are both of these?
Non-polar covalent.
So what's the only type of IMF?
The LDF.
LDFs, and with what do LDFs vary?
To like,
Well, again, we talked about it, which one's gonna be stronger LDF?
The bigger one.
The bigger one. Remember the science one, I mean, the one you answered without all the science in it?
yeah,
You need the science in it.
so since DR is bigger,
Since, yeah, so CBr4 is a bigger molecule than CCl4, it's got stronger LDFs. Therefore, higher boiling point. Now, if you missed any of the Lewis dot structures in any part of that, I want you to go ahead and redraw them correctly. Some of y'all messed up on the SO2 one.
Can we go over that one? 'Cause I don't understand.
Can we go to the last one?
I got
It says hydrogen, I don't know.
somehow got all the polarities right. I got 8 of those.
I don't know, this
That's
is
the one.
Okay.
The worst part about these is if you miss,
Uh-huh.
the worst part
Uh-huh.
about these is if you miss one part, you miss.
Well, not necessarily, that's not true.
Some of them.
Yeah, like I.
Okay,
know
because
I'm
if you
trying
did the
to-
wrong Lewis dot structure, but you had the shape and the hybridization and polarity based upon your wrong structure, I didn't take points off for it. I put okay by it, meaning that it's not the right answer, but I didn't take points off. You only lost the 2 points. It's 2 points for the Lewis dot structure, 1 point for the other things. Okay? So, SO2. What's the first thing we do when we draw the Lewis dot structure, when we want to draw it?
Yeah.
Count electrons. It's gonna be 6 times 2 is 12 plus 6, 18 electrons. So obviously sulfur, oxygen, oxygen. So it's 2, 4, 6, 8, 10, 12, 14, 16, 18. What's the problem here?
Sulfur doesn't have enough electrons.
Sulfur only has 6, it needs 8. So what do we do?
Put an equal sign on one of them. Or put another.
Steal from the rich,
Another one.
share with the poor, and make it double bond.
You know what I mean.
Now,
Mm-hmm.
what's the AX formula of this?
AX2E.
AX2E. Now, this is not the answer to anything. It's not the shape, it's not the hybridization, it's not the polarity. It's just a way to get there. It's the code, it's the Rosetta Stone for you to get those other things. Okay? So, you go and look on your sheet, AX2E is what shape? Shape.
Oh, bent.
Bent. The type of hybridization, 2 plus 1 is 3, so what type of hybridization adds up to 3?
SP2.
SP2. And is it going to be symmetrical or asymmetrical?
Asymmetrical.
Because it's bent, it's going to be asymmetrical. Therefore, polar. Yes, sir.
Can we go over E?
Yeah, I'm working on it. Keith, did that answer your question?
Oh, yes.
Okay. Where was the confusion on this one? Did you miscount electrons?
I think I did. I put 2 double bonds.
Yeah, so if you only put 16 electrons and did that, that's when you would use 2 double bonds. So you just make sure you count and get the number of electrons right.
That's where it gets us, is the counting.
Yeah, I know, it's over 10, so you ran out of fingers. All right, now, HBrO3. When you have hydrogen and oxygen in the same compound, what's true?
They bond each
Hydrogen's gonna bond to the oxygen, not to the bromine. Okay? Hydrogen and oxygen have that thing for one another. So,
Good job.
1 plus 7 plus 18 makes 26 electrons. So it's gonna be bromine, oxygen, oxygen, oxygen. Now, see, the hydrogen would fit right there. And Lewis dot structure, everything would work out, and it would look just like it's supposed to. But hydrogen doesn't bond to the other nonmetal, it bonds with I'm struggling today, it bonds with oxygen. Now, you could have picked any one of those three oxygens to put it on. It's an equal opportunity bonder. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Do we need to form any double bonds? No, if it ain't broke, don't fix it.
That's where I screwed.
Now, notice the directions are for every essential atom. For each of the following, okay? So around the bromine, what's my AX formula? AX3, just E. It's pair, not total electrons, it's pair. So you look on your cheat sheet now, and you see that that says trigonal pyramidal. Three plus 1 equals 4, so what type of hybridization adds up to 4?
SP3.
SP3. And is it symmetrical or asymmetrical?
Asymmetrical.
You got lone pair here, and you got the hydrogen over there that's not balanced by anything, so it's asymmetrical, therefore it is
Polar.
polar. Now, what's the shape around the, what's the deal around the oxygen? What's the AX?
AX2, E2.
E2. 1, 2. You don't only, this is a different central atom. This is dealing with this one. Central atom's just this. So, again, I know the shape of that's gonna be bent. So it's gonna be bent around this. 2 plus 2 is 4, so it too is sp3 hybridization. And the whole molecule is polar, so I mean, you only have to say polar one time for the molecule.
I missed the whole section.
All right, so I'm gonna let you guys work on any of the other ones that you may have missed. Yes, sir.
How come the A isn't ionic? 'Cause isn't it aluminum metal?
It is, but it's so far over to the right that the difference in electronegativity keeps it as covalent.
Get me to start the video.
I never missed the hard ones.
And then when you're finished, staple the corrections to the top of the answer sheet. And we'll make 2 piles up here. Throw some bombs.
Like, it's the ones that you think, oh, that's easy, then I'm just destined for this.
It's a double one, but do any come off the oxygen? So,
From each oxygen.
I wish I used back.
Do you want them up here?
Just 2 piles right there, yeah.
It's vicious. Thanks, Mike.
I got one thing wrong. I was being stupid and messed up the AX formula.
two double bonds and then you have like 2 sets of pairs. Like 2 double bonds and 2 sets.
Hey, you see Jack Stewart's new TikTok?
Oh,
The one at the basketball game?
Oh my god.
He got like 2 million views. 1.4 million views.
What was it?
He just walked into a song, he's just like.
that was loud.
Did you see the comments? Yeah, if sour cream was a person. Somebody has been like, with the senior goes, you did this in our school and felt no shame about it?
He went famous the wrong way.
I mean,
Did I not? Hold on, I was kind of.
I want to put the, oh, here's a,
What the frick was
here's
that?
another text.
Dude, in my kindergarten class.
Dude, somebody said.
Okay, so we're all good?
Somebody said, give me back my dream journal.
All right, now, y'all watched the video yesterday, and I basically gave you all of the information that you need to fill in these notes. Did I get you his notes?
I know.
I missed you. Pass that back to him, please. So, you should have, for all of this, the chemical formula, shorthand, telling the different types. So if you took notes at all yesterday off the video, you can fill in all of this stuff here, okay? Now, I will tell you this. A tightly bound group of covalently bonded atoms that behave as a single particle, that's gonna be called a polyatomic ion. That's a polyatomic ion. That's what these are up here. I just gave you a list of common polyatomic ions. What is the prefix poly mean? Many atoms. They're covalently bonded, but they carry a charge. So nitrate is NO3, but it's got a -1 charge. Okay? So polyatomic ions, tightly bound group of covalently bonded atoms that behave as a single unit and carry a charge. Now, I was going back and looking at it. I can't remember my logic. Now, you gotta realize I've been doing this for a very long time, and these notes were written probably in the 80s. Chemistry hadn't changed that much. Okay, I'm trying to remember what my thought process was and why I put that in here, but we're dealing with empirical formulas and ionic compounds, okay? Well, an ionic compound, when a metal is attached to an OH, it's gonna be ionic, but we call it a special type of ionic compound, it's gonna be called a base, opposite of an acid. Whereas all other ionic compounds, they're gonna be called salts. That's just an old school. So normally we hear about table salt and we think that, ooh, that's just, salt. But salt is a general name for any ionic compound. Except when the negative ion is OH, then we call it a base. When the positive ion is hydrogen, we call it an acid. Now we'll come back to this. Okay? But if I want to name ionic compounds, which one do we name first? The metal. Okay? What's the charge going to be? Positive. Name the positive first. Now, here's the deal. If the metal is a transition metal with more than one possible oxidation state, determine the oxidation state is specified and indicate the charge with Roman numerals in parentheses. Now, how the heck are we going to know if it's got more than one oxidation state? Well, we're going to look. Okay, everybody get the color periodic table out that I gave to you. Yes, that one. Yes, that one. Okay?
The one in the back that we didn't.
You can just shine it up here, actually.
Yeah, I was gonna say that second piece on that.
That's what Mr. Hobbs.
All right. When you look here, the transition metals, first off, we know transition metals are here. Alkali metals, see the little number 1 above lithium, sodium, potassium, rubidium? That's its oxidation state, okay? It only has one possibility. Everything in group 1 is +1. Everything in group 2 is +2. They have 2 valence electrons, they want to lose both of them. But transition metals have more than one little number above the symbol. That's how you know it has more than one oxidation state. There's more than one number. So you'll have this periodic table, you have access to it, you're not going to have to memorize anything. The reason is because some of them only have one. Some have more than one. And even over here, these aren't transition metals, but they're still metals. And they have more than one oxidation state as well. So when we're naming ionic compounds, we're going to have to know whether or not if it's an ionic compound, we're going to have to know if the metal, does it need a Roman numeral in the name or not. And so we're going to look on the periodic table and we're going to do a whole bunch of practice of this in the next 5 minutes or so. But if we're going to name the positive thing first and the negative thing last, the negative thing is going to be an ion. The negative is going to be an anion. It's gonna be either a monatomic ion or a polyatomic ion. Now the name of the cation is easy. It's just gonna be the name of the element. Sodium, potassium, rubidium, barium, magnesium, aluminum. Okay, so we don't have to change the name for the first thing. You do only have to know the one positive cation, which is ammonium, NH4+. Okay? So you're just gonna have to be able to recognize that. NH4+, it's the only polyatomic cation, positive ion. Everything else is gonna be a middle. So we're gonna name the negative ion last, okay? That negative ions only end in "ide," "ite," or "ate." This is what I was talking about at the very end of class yesterday. "Ide," "ite," or "ate." So, if it's monatomic, it's gonna end in "ide." If it's polyatomic, that means it's gonna have oxygen with it. It's gonna end either in "ite" or "ate." I-T-E or A-T-E. Now the relationship is the ite always has one less oxygen than the 8. Ite is always one less than the 8. Now the 8 doesn't tell me that it's 3 oxygens or 4 oxygens. It depends upon what the oxygen's attached to. The 8 is generally the higher oxidation state, the highest. Ite's the one below it. But sometimes there's more than 2, and so we it doesn't tell us. But if you know the 8, ite is always one less. So SO3, 2 minus, is going to be sulfite. And these are all on that sheet that I just gave to you, sulfite. So if this is sulfate here, then what's the formula going to be of sulfate? No, this is sulfite is SO3. So it's going to be SO4. 8 is always going to be the higher, one more. Ite is one less. Okay? So let's go backwards on this one. NO3 minus is nitrate. N-I-T-R-A-T-E, nitrate. Use the Latin preservatives. So what would be the formula of nitrite? NO2 minus. Same everything, just one less oxygen. So phosphate is the more common one here. Phosphate is PO4 with a 3 minus charge. So what would be the name of PO3 with a 3 minus? Phosphite. Okay, I'll slow down for a second. You guys are writing fast and furiously. Okay, so we learn the names of the ions, just the 8 and the I. If it's monatomic, fluorine is the element, fluoride is the ion. Chlorine is the element, chloride is the ion. Oxygen is the element, oxide is when it's the ion. Okay, so there's only 3 endings possible for these compounds. Ide, ite, or ate. Okay? So we can just fill in the rest of these.
What about
What about what?
the ClO minus, like just the plain one?
The ClO minus, right? Okay, good question.
Since that one's gonna be chloride, there's no chlorate.
Good question.
Oh, there is a chlorate.
There is a chlorate. Okay?
This is just confusing.
ClO3 minus is chlorate. So ClO2 minus is what? Chlorite. Okay? But there's also a ClO minus and a ClO4 minus. Chlorine has a plethora of possible positive oxidation states. I'll show you how that can be here in just a second. So, when we're going to name the ion, we're out of suffixes because we only have these 2, so they go to a prefix. Okay? So this has one more oxygen than the chlorate, so we use the prefix hyper, except they take the high off and just call it perchlorate. but it comes from hyper, meaning over or above. If you're hyperactive, you're overactive. Perchlorate means one more oxygen than the 8. What's the prefix for below that's similar to hyper?
Hypo.
Hypo. Now in this one, they leave the high on and call it hypochlorite. One below the chlorite. I guess they don't want you to feel sorry for it and say pochlorite. Okay? Now, if anybody watched the end of the video, you heard that one already. Okay? So, it's really just the halogens that do this. Now here's the amazing thing. This is all about chapter 5, the periodic table. Okay? If I know chlorine, all of these elements are going to bond in the exact same way. So if chlorate is ClO3, what is bromate going to be? BrO3 minus. And what would iodate be? Besides a miracle. Iodate.
Iodate? Wait.
Yeah, iodate. What's the formula going to be? I already said IO3 minus would be iodate. Okay? So, therefore, iodite would be IO2 minus. Hypoiodate would just be IO. Hypobromite, just BRO. Bro. They're all going to be the same. So if you know one, you can figure out the rest of them if you know this simple nomenclature. Does that make sense to y'all? Really, this is the only family that does the hypo and the per, but there is permanganate, which is over here, right there, permanganate, MnO4. But I've never ever seen a manganate ion. But what would the manganate ion be? Permanganate is MnO4. What would manganate be?
5.
No, per is above,
Three.
so it's going to be 3. It's going to be, the per is the highest, because it's hyper, it's above. So perchlorate means it's above chlorate, so it means it's got one more oxygen. Okay? So that's the only other per that I know of. There are some other pers, you know, that aren't nearly as common, but you just need to know this means one above, this means one below. So when you have more than 2, you have to use those prefixes. Okay? Now here's the good news for you guys. You're always going to have that sheet with the ions, so you're not really going to have to memorize them. Okay? Not going to have the back, which is the flow chart, which I'm going to get to. But so here's the deal. How can chlorine have all of these different oxidation states? Chlorine has 7 valence electrons. So we would normally just, it's like this. Now, we don't normally draw our Lewis dot structures this way, but I kind of want to show you. If I'm ClO minus, I can put an oxygen in here with its 6 electrons, and then put that extra electron right there for my ClO minus. Okay? So how many electrons does chlorine have involved in bonding right here? Just 1, right? But because chlorine is less electronegative than oxygen, it's forced to be the positive one. Oxygen is going to be the negative one. Electronegativity, the attraction for the electron. So in this case, chlorine is +1. Now, by the way, it's the hypochlorite ion that makes bleach. It's sodium hypochlorite. That's in any bleach, Clorox, great value. Anytime you get a bleach, it's sodium hypochlorite. Okay? Now, by the way, we talked about soap. Clorox does nothing to get the dirt out. It just makes whatever dirt won't come out white. It just bleaches it. Okay? So it blends in, so it gets rid of the stain. Okay? So it doesn't, the detergent's supposed to get the dirt out, but whatever doesn't come out, the bleach just makes white. Now, if I go to ClO2, we do this thing called that coordinate covalent bond, where the oxygen, remember the electrons can shift, and so it's going to share, both electrons are going to come from chlorine in the shared pair. So now how many of chlorine's electrons are involved in bonding? 3. So we say it's in the +3 state. Now oxygen is always -2, minus 4, notice it's adding up to minus 1. So now if I put the third oxygen over here doing the exact same thing, now how many of chlorine's electrons are involved in bonding? 5. So we say it's plus 5. And then lastly, plus 7. So the oxidation state tells me the number of electrons that are involved in bonding, and that's why we put the sign in front. It's not really a plus 7 charge. It just means that 7 of its electrons are involved in bonding, being shared. Okay, so that's the difference between plus 7 or 7 plus. If I say 2 plus, that means it's a complete transfer. That's the actual charge. The sign in front tells me that it's the oxidation state. Now, we're really behind.